everybody, and welcome to another video on the channel. Today we will be talking about sum to product and product to sum trigonometric identities. More on that later. But without any time to waste, let's move on to the real part of the slideshow. What are these identities exactly? These are mathematical formulas that convert between product and sum of trig functions, which is pretty much explained in the name itself. These are very essential for simplifying complex trigonometric expressions, especially at higher level math like calculus, physics, etc., and also in engineering. While I know physics and engineering are completely different from math, they do have a large part in math itself. And also in just any competitions like in Olympiad competitions, these identities will be used as they are slightly more complicated than the identities that are normally taught in a very introductory trigonometry course. So that's why I'm covering it today. There are 4 key formulas for product to sum identities. The first is cosine A cosine B, which is half of cosine A minus B plus cosine A plus B. The second is sine A sine B, which is half of cosine A minus B minus cosine A plus B. Then we have sine A cosine B, which is equal to 1 over 2 sine A plus B plus sine A minus B. Then the fourth and final formula is cosine A sine B is 1/2 of sine A plus B minus sine A minus B. So that's about it for the 4 formulas. If you're like, oh, that's very difficult to memorize, I have a quick cheat sheet / hack for you that you can use to help you memorize it a little more quickly. I, in fact, used this myself, and it helped a lot. So, what it is almost to create a table. For the first formula, we can say it's cosine and cosine, where both of them, it can be in any order. So then, of course, there's 1 over 2, but there's 2 cosines. So on the other side of the table, we could write cosine, cosine. But then, since there's an A minus B and an A plus B and a plus, and it doesn't matter which order you arrange them in, it could just as well be cosine A plus B plus cosine A minus B. You can say a plus at the beginning to show that there's a plus in the middle, and then just generally remember the fact that there's going to be both A minus B and A plus B. You can do it for the second, third, and fourth, and so on, with similar rules with the one that I showed you, the example that I given you above. And on the bottom it shows memory tips, but I would honestly remove this one and also this one, because always multiply by 1 by 2 is probably the biggest thing that I've seen people forget. Not as much the sign convention, but forgetting to multiply by 1 over 2, because in just trying to memorize this part, they often forget that there's also a 1 by 2 over here. I've done it myself, and trust me, it's not very funny when you realize that all the hard work you put into solving a very difficult trig problem had just to come out that you forgot to multiply 1 over 2. I'm telling you, it's the exact opposite of satisfying. Over here is the sum to product identities and the 4 key formulas over here. Now, for memorization, you can always, of course, use the table method I showed you, or any other methods. Of course, if you have any other methods, leave them down in the comment for any viewers to see, as it would really help all the people that watch my videos to understand more about these topics. Now, the 4 key formulas are sine A plus sine B, which is 2 sine A plus B over 2 cosine A minus B over 2. Sine A minus sine B, which is 2 cosine A plus B over 2 sine A minus B over 2. Then we have cosine A plus cosine B, which is 2 cosine A plus B over 2 times cosine A minus B over 2. Then cosine A minus cosine B is -2 times sine A plus B over 2 sine A minus B over 2. A memory tip is to always multiply by 2 or -2 in the case of the final formula. Use the half angle formulas A plus B over 2 and A plus B a minus b over 2. It's important to remember this, and also to use half angle formulas just in general if you're trying to simplify these types of expressions, especially if you have variables. This is going to be our first example. The problem is to express cosine 3x sine 2x as a sum, and our task is to convert this product into a sum of trigonometric functions. Now, which formula should you use, and what are your a and b values? So let's think about it. This is a product of cosine and sine, and let's look at our product to sum formulas. Now, it's cosine 3x times sine 2x, and since this is cosine and sine, the formula would be 1/2 of sine a plus b minus sine of a minus b. If we write that down over here, we get 1/2 of sine a plus b, then minus sine of a minus b. Now, over here, what's going to happen is we got to go on to our next step, which is substituting everything. So 1/2 of, instead of just the variables or the placeholder values, instead of really variables, I like to call them because we're substituting in for them, it's sine of 3x plus 2x, which is 5x, minus sine of 3x minus 2x, which is x. And that's about all the steps we're using in this entire problem, all the reasoning and logic we're using, and everything over here is at the bottom. And of course, here is the solution. Now, just a quick note, I've said this multiple times before, but I want to say it again. This slide is really for the people who are done, like who finished it before I'm done explaining and don't want to wait. So they go on to this slide just to make sure that they understand everything and that they got the answer correct, instead of having to fiddle around to see when exactly I finished my explanation. They can just look for the transition, and there they go, they got the answer. And pretty big over here, solution, cosine 3x times sine 2x is 1/2 of sine 5x minus sine x. Our second example is a sum to product problem, and our problem is to find sine of 75 degrees plus sine of 15 degrees. Our task is to convert this sum into a product and find the exact numerical value, and which sum to product formula would we apply over here. The hint is both terms are sine function, and you'll end up with familiar angle values. Now, I just want you to take a note on the second point. This just says that we won't be rounding, and we will take the exact form right as it's written. The formula we will use for this is 2 times the sine of a plus b divided by 2. Over here, if we put divided by 2, and then this will be times, because we are using a sum to product formula, times the cosine of a minus b divided by 2 instead of a plus b divided by 2. And then what will happen is you'll find out that this equation actually works out quite nicely. So our next step is to substitute. This becomes 2 of sine 75 plus 15 is 90, 90 over 2 over here. And then we have cosine 75 minus 15 is 60, so we have 60 over 2 right over here. This is some of the first steps of the problem, and then after that, this will just be to algebraically simplify. So our next step after we substituted everything is to get this down even further. So we have sine of 45 times cosine of 30. Then after this, what we're going to do is we're going to substitute in for the values. So we have 2 times sine 45, which is the square root of 2 over 2. If you don't know these values, I highly recommend you watch my unit circle video and my introductory trigonometric values video, which is also included in the unit circle. But I think there's also a separate video which explains the other values and just common values in general instead of just explaining the unit circle's purpose. The final step to do over here is to simplify further. Now, since there's a 2 over here and a 2 over here, these cancel out to give 1. So then, square root of 2 times square root of 3 over 2 is the square root of 6 over 2. Square root of 6 divided by 2, which is the rationalized form, which you will normally see as the answer in most textbooks. But sometimes some people will also give it as the square root of 2. If you factor it out, that becomes the square root divided by the square root of 2. But for now, we will stick with the rationalized answer, as that's what we got just by pure simplifying instead of taking a bunch of radicals. So that's the solution to the second problem, and that's basically how it works for the sum to product formula with numerical values. Here is the solution. Over here is the value, and the solution is, of course, as I said, the square root of 6 divided by 2. Just to make sure that you know it's in rationalized form. So if some of you got square root of 3 divided by square root of 2, that is also perfectly acceptable. But sometimes textbook will say, or problems will say, to put it in rationalized form, in which, in that case, the other answer is incorrect. So that's about it for our second example. And here are our real-world applications in calculus, and then in physics and engineering, and also in problem solving, basically in Olympiad questions for math, or just any general problem you're doing in math, maybe something you found on YouTube from YouTubers saying it was a very difficult question, and when they have the explanation, it turns out that it uses one of these trigonometric identities. So in calculus, integration especially, it makes impossible integrals solvable. Example, sine of 3x times sine of 5x dx becomes way easier with trigonometric identities. Then in physics and engineering, wave interference, basically it helps us understand how waves combine, because sine waves and stuff are just sine waves. Then signal processing, analyzing radio and audio signals, which are also waves or sine waves. And then acoustics, which is predicting sound patterns, which again uses sine waves in return, which is your trigonometric function. In problem solving, of course, it's mostly about simplification, and sometimes can actually be the final step in problems, but normally this is either an intermediate step or the first step you do. When to use each type, normally this is self-explanatory, but there are also what you're also doing in physics and engineering. So if you have products of trig functions to integrate, you need to use product to sum. If you have equations with sums of trig functions, of course, sum to product. But then if you need to analyze frequency components and signals, not singles. And then if you want to simplify multiplication of waves, it's also really useful for product to sum. And then if you want to use sum to product, it'll be if you want to factor trigonometric expressions, of course, or you're analyzing wave interference problems in physics/engineering. Now, here are a few practice problems with their examples. I won't go over them. This could be just a little bit of homework to understand. And of course, there are a few hints over here. And then some of these actually is a little different when you realize that cosine 6x times cosine 4x to a sum, that's pretty simple, and problem B is also pretty simple. But problem C, I could definitely see people using the hint, because when you convert to product form, you'll be able to do many more algebraic manipulations after that to get the final answer over here. Here is the practice strategy. Basically, this is just a general strategy. I'll let you read over this slide. It's just simplifying, identifying the pattern, etc., etc. Normally, and also to check your answers. But what I'd say the main thing over here, even though it looks like it's a side thing, I'd say is to avoid mixing up the coefficients, mixing up the signs, and making sure you don't forget the 1 by 2 in the sum to product formulas. At last, here are a few key takeaways just to make sure you remember. If you didn't know already, these are the key takeaways from this video. So if you only had about a minute or 30 seconds to watch this video, this slide is what I would watch. To remember these points: product to sum, product, of course, to sum with 1 by 2. Sum to products is sum to products with 2, of course, and then divided by 2 in the actual trig functions. Then both types use combinations of a plus b and a minus b. And of course, if you're doing arithmetic with it, practice with simple angles first before you move on to angles like 58.851283. I don't think it would be very pleasant to practice with things like that. So that's about it for this entire video, and thank you so much for watching once again. Your support is greatly appreciated, and if you had the time and if you enjoy my videos, please make sure to like, subscribe, and hit that notification button. It really helps me out a ton. I know everyone says this on YouTube, but it generally gives me such a good confidence boost, and also the fact that I'm really helping people and people appreciate my work on this platform. So that's about it. Thank you so much. Please make sure to comment down below any suggestions, and see you in the next one. Bye-bye.